Aloha and welcome to our video on severe storms. In this video, we'll explain the formation of a thunderstorm, we'll describe the conditions needed for a tornado to form, and then we'll identify the conditions that must exist for a hurricane to form as well. Okay, let's talk about thunderstorm development. Now, thunderstorms are characterized by a lot of vertical development, which means we have a lot of change in altitude with the storms. There's a lot of uplift, and that uplift is what's going to cause an awful lot of the products of a thunderstorm per se. So we're going to start off here in our cumulus stage. We have just cumulus clouds. There's going to be warm air rising. You're going to see this uplift coming up and things of that nature. And then we get from here, it's going to continue to build. So this storm is going to continue to build upwards. You're going to see the clouds bubbling up and things of that nature. And we get to our mature stage of a thunderstorm. Now, in the mature stage, we have all of these water molecules moving up and down. They're going to generate that static electricity, and that static electricity is released in lightning. So that's how we get our lightning for these storms. This rain that's coming down, this precipitation that's falling, can get caught in the updraft, and it can continue to build and build and build, and this is how we develop hail. So now we can see how we're getting lightning and hail from these thunderstorms from this uplifting of all of this material. And that's what's going to cause these storms to develop so strongly. We'll look at tornadoes a little bit later, but they're also a product of this strong uplifting. That's what causes these storms. Now, when the storm runs out of energy, we get to the dissipating stage, and you'll see the rain start to slow down. Now, when it dissipates, there's a couple different ways this can happen. You can have a nice gentle dissipation like we see here, where the rains just kind of taper off, the clouds are just kind of, you see this down coming, all of this stuff's going to be collapsing down. There's no longer the uplift, so all of the precipitation and stuff's going to just keep falling, no more hail. It just kind of pitters out a little bit. But you can also have this where it's rapid. So you can have all of this uplifted material just give up the ghost, so to speak, and it'll all just drop down, whoosh, at one point in time. And this is what causes a downdraft. And we can have downdrafts where the winds produced by this downdraft of material are going to be in excess of 200 miles an hour. And we can see this because you'll have a point of impact, and then everything like trees and stuff will all blow down away from this point of impact. So you can see that it's all straight line winds that have caused this damage. And that happens when you have these thunderstorms. They give up their energy and it just kind of goes down. The bottom falls out of it, so to speak. And you can actually see that occur. So thunderstorms are pretty cool. When you see them, the safety is to get inside, get out of their way. Don't be on electrical devices in case it strikes the house or something of that nature. Watch out for the lightning, watch out for the hail, because they are fairly dangerous. But remember, it's from a cold front, so it's going to be kind of rapid in their progression. So the storm will come and then it'll be gone in a short period of time. So continuing along with our thunderstorms here, we can see we have our thunderstorm over in this area here. We have this updraft going on over here. But you can see that we have weaker winds blowing in one direction along the surface, and they could be weaker because of the friction of the ground. And then we're going to have these stronger winds aloft. And because of that, we get this kind of circular, this horizontally circular axis of spinning going on here. And then when that reaches that updraft that we see here, we can see how it's going to take this circular nature and it'll actually turn it. You can see it lifting it up here into where the clouds are. And then we get into this mesocyclone, which we'll see here, where we have this air is inflowing in with this updraft and we're getting this circular nature here. And as that happens, it's going to cause the entire cloud to rotate. So you know it's a bad scenario when you see these thunderstorms. This can be like a mile wide, and this whole thing is going to be turning like this. You're going to see this whole thunderstorm start spinning, okay? And when that happens, the net result of that is we'll see from the bottom is where we form our tornado, and that's where it'll work out that way. Inside the tornado, you're going to see a bunch of smaller cyclones spinning. So they're really devastating. We'll talk about that a little bit more in the next slide, but this is how we form a tornado. So when we're talking about tornadoes, we measure them on an intensity scale named after a scientist by the name of Fujita. So you'll hear about this Fujita tornado intensity scale, or the Fujita scale. Now, their intensity, and this is a little bit different because we're looking at wind speed estimates and things of that nature. So we go from an F0, where we're going to have light damage, broken branches might happen, small trees might get pushed over, signboards, all the way up to an F5 tornado, where the wind speeds can be in excess of 419 kilometers per hour. And this is where we see houses being lifted off their foundations, automobiles flying through the air in excess of 100 meters. We can see the bark ripped off of trees. So these are very strong and damaging storms. So we use the Fujita scale to kind of rate these tornadoes and see how bad they are. So in this picture here, we're looking at a cross-section of a hurricane, and a couple different things we want to know. We're going to know that we have the wall of the hurricane, which is this outer edge here, and then we have an eye wall inside. And inside the eye of the hurricane, we actually have a moment where we have clear skies, because it's going to be open to the sky above here, and it's going to be relatively calm. However, just inside of the eye wall is where we're going to experience the strongest winds of the hurricane. So what we notice is we have this surface convergence of the wind that's going to be blowing around this way. And as it's blowing through, it's going to spiral its way up through the hurricane here, up to the top. And then from there, we'll get some outflow at the top, but we also will notice that we get some downdraft coming down inside as well. And that's what kind of clears it out, is that downdraft in the middle of the eye of a storm. Now, as the direction of this hurricane is traveling, what it's going to do is, because it's so strong, it's going to be pushing up this water ahead of it. And this is what we call our storm surge. And this can be just as damaging as the hurricane itself, because we can add like 15 feet of water in front of this hurricane as it hits shore. So let's take a look at how we rate hurricanes in the next slide. And just like the tornadoes had a rating scale, so do our hurricanes. And we use the Saffir-Simpson hurricane scale. So we can have a category 1 to a category 5 hurricane, and they're determined by their wind speeds. So at about 119 kilometers per hour, about 75 miles per hour is for our hurricane. And then we'll notice that we can get in excess of 250 kilometers per hour. Now, as I mentioned in the slide previously, we see this storm surge coming on here. With a category 1, we get about 1.2 to 1.5 meters. So we're talking about 3, 4, 4.5 feet of water increase as it's pushing onto shore, all the way up to excess of 15 feet here, where we can see with a category 5 hurricane. And that causes a lot of damage. That's going to cause that coastal flooding and things of that nature. The winds are going to be severe. It's going to be complete roof failure. You get a bunch of water coming down. So it's just a big storm that's going to be kind of concentrated into this area, and it's going to push ashore, and that's where we have our issues. Okay, so as always, they'll explain these things a little more detail in the lessons. Good luck on your quiz, and we'll see you in the next video.